Hi, everyone. Really happy to be here. Great crowd. I want to talk about how Applied Intuition is bringing intelligence to vehicles all over the world. And we think about things in terms of scale, and we work with all of the industries that you see represented here on this slide, and I'll tell you a bit more about how we actually do that. Before we dive too deep, though, I do want to level set on a few things. I feel like here in the Bay Area, especially in the tech sector, it often feels like there's just a handful of companies that get all of the attention. Tesla gets a ton of attention. We see Waymos all over in San Francisco. Waymo gets a lot of attention. And everyone else in the industry is sort of a footnote that maybe barely gets mentioned. And so if you're here, you'd really think that Tesla's got to be the market leader and Waymo's this enormous operation. The truth, though, is the industry looks like this. Right? So Toyota is the #1 vehicle maker, followed by Volkswagen, Hyundai, Stellantis, and General Motors. This is data from 2023, which is the most recent year where there's good data available. There were over 90 million vehicles made that year, and Tesla is only 2% of the global market share. And these are all incredible companies with great technology and great brands. In fact, some of these companies are over 100 years old and have survived all kinds of interesting macroeconomic changes during that time. And I hope that Applied Intuition someday can reach 100 years. That would be incredible. And also the market shares of these companies don't change that often. There's a lot of new companies that have come up in the last few years, but even with all of that, there's just this enormous factor of like you actually have factories, you have these huge assets that exist to make these vehicles. Those things just don't change very quickly. And so even with all of these new players and change, the market shares don't actually change that much. And lastly, these companies are all extremely important to the global economy and also to the regions where they exist. Tens of millions of people at these organizations all over the world. And I want to highlight just a handful of core competencies that exist in the vehicle industry, and then how we complement those core competencies. So hardware engineering and systems integration. A modern vehicle has thousands of components, and this competency is sort of the lifeblood of the vehicle industry. You design high-quality components, you integrate them together really well, and you make a very high-quality product. Functional safety is also a very strong core competency of the industry. Vehicles today are mechanically really safe, and the amount of testing and validation that goes into these systems is so extensive that typically we're not even thinking about the safety of a vehicle these days when you're buying it. You can assume that the vehicle is actually quite safe. And manufacturing excellence is incredible. I mean, if you've ever had a chance to be in a modern vehicle factory, you'll typically see more than one vehicle come out of the factory every minute. And so no matter how you think about that, it's an impressive thing that, like, as humanity, we're able to build things at this scale. And I want to contrast this, though, where the industry is generally weaker. So the industry is generally weaker in adoption of AI technology and bringing that technology to the actual vehicles themselves. And it's also weaker in the topic of software-defined safety, right? So as you add more advanced AI technology onto these vehicles, you need to ensure that it's safe. And of course, if you're using these vehicles, whether this is for transporting your family or for important industrial applications, you need to ensure that these systems are going to behave very reliably and safely. And so these latter two areas, this is where Applied Intuition comes in and how we're working to scale this technology to the industry. We do this through 3 product pillars. So tools and infrastructure, vehicle operating system, and autonomy. Within tools and infrastructure, we have a focus on autonomous systems. However, autonomy actually touches all aspects of vehicle software. And so there's the spectrum from software all the way to hardware, and our tools and infrastructure has to support that entire development lifecycle for production systems. And in fact, many of the advanced driving assistance systems that are on the market today, probably a lot of the vehicles that you all drove in to get here, were developed using our tools and infrastructure over the past 8 or 9 years. Secondly, for our vehicle operating system, we created a modern software platform that allows vehicle makers to develop software for vehicles that is roughly as easy to build as you might build a smartphone app for a phone. And this is a huge unlock for actually enabling AI technology to productionize in vehicles globally. And lastly, we build autonomy products. These are available to the whole industry, and it's not just cars. We also work with trucks and planes and drones. We work in really all domains, and these things are fundamentally built using our tools and our operating system. And so we scale this technology by working with all of the great vehicle companies all over the world. And we're very much long-term focused. In this industry, you have to recognize things take years to do. There are factories that produce these things, and it takes time to get systems onto components that are actually coming out of the factory, and that's what we work on. The data engine is a core part of our technology and a core part of our strategy. We actually gave a much more technical talk on this topic yesterday, which perhaps you had a chance to attend. But the key point here is we do large-scale data collection actually in many different areas. And there's a big element of processing, labeling, training, and evaluating that. And this is actually where we use Ray as a really meaningful part to scale all this work out to a huge number of GPUs. Just to provide another example here, so this gives a sense of our driving assist product. We call this SDS for cars. That's our self-driving system for cars. This is built using our tools and operating system. It's an end-to-end architecture, and it's a competent self-driving system. And we're also able to use vision language models. You can see up on the upper left, the model is actually describing what it's thinking as it's driving down the road. And with Ray as a core part of our HPC infrastructure, we just keep improving the system. Like every week, the system is materially better and a more competent driver than it was the week before. We're also pushing forward the state-of-the-art in these fields. So in this video, just as an example, this is our end-to-end planner, and it's being evaluated in a closed-loop neural simulation. And so the sensor input is generated also with reactivity by our neural simulator. And our research team's work actually spans across end-to-end tech, neural sim, world foundation models, vision language models, and also reinforcement learning. And we're also proud that we've had the honor of winning a handful of awards in recent relevant conferences. Now, I want to talk about how we actually bring this technology to the industry, and what does it mean to actually scale this. And so I'll highlight a bit about how we work with a handful of industry customers. Stellantis is the 4th largest vehicle maker by sales volume globally. And Stellantis is using parts of our vehicle operating system for their next generation vehicles. And they're going to be able to bring a state-of-the-art in-cabin experience to production. Now, not all of the information is public, so I can't go into super great detail here, but it's going to be incredible, and it's absolutely going to be a state-of-the-art world-class experience. They need the ability to run the latest applications in their vehicles, and it's not as simple as a software upgrade. You have a very complicated electrical architecture, and all of these companies, they have a deep history of their systems. And you have to remember that when vehicles are built, these are built for 15 years. It's not like a GPU or a phone that's designed for 1 or 2 year lifespan. And so when they make a commitment, it's a big commitment, and this will scale to millions of vehicles. But these changes do take a few years to ultimately make it into scaled production. But that scale absolutely will come. 2 months ago, we announced a 6-year strategic partnership with Komatsu for our entire technology platform, spanning our tools, infrastructure, operating system, and autonomy technology. And this was actually the most significant technology investment in Komatsu's 104-year history, and this will shape the future of the mining industry. Komatsu today is the 2nd largest mining OEM in the world, but they're also not new to utilizing advanced technology in their systems. In fact, they're a pioneer in this type of technology. 20 years ago, Komatsu began running level 4 autonomous mining trucks at mine sites in Chile. And just think about the state of AI and compute in 2005. You only had CPU, no GPU. And this was after the original DARPA Grand Challenge, but still before the DARPA Urban Challenge. So that sort of places where this was in the industry. And so today, there's over 750 autonomous mining trucks active around the world, and they move material at a rate of 6 million tons per day. In the 20-year history, in total, more than 10 billion metric tons of material have been moved autonomously. And some of these trucks that are hauling material every day, they've logged more than 100,000 hours of haulage. That's not miles, 100,000 hours of haulage. However, there are some pretty material drawbacks with a 20-year-old technology solution. So in order to actually make this work in a mine, you have to spend many millions of dollars installing all kinds of advanced infrastructure, a lot of it around networking and wireless technologies. And the vehicles that are running, they have to connect to a fleet management system 100% of the time, and I do mean 100% of the time. So if any vehicle is disconnected for 5 seconds, the entire operation comes to a stop. And that's because the safety case lives in the fleet management system itself, by knowing where all of the vehicles are at all times. And so the result of this is only the largest mines in the world can afford this kind of autonomous solution. And so it's limited in its ability to scale because of the bespokeness of the system, even though it has a real impact. So there's huge infrastructure costs and operations costs. The total investment is just too big for most of the market. And what's the result? The result is that today only 3% of the surface mining trucks in the world are autonomous. And Komatsu wants to scale to the other 97% of the market, and that's what we're helping them to do. And there's about 100,000 surface mining trucks in the world. What that means for us is every vehicle needs much greater onboard intelligence to actually handle all of the scenarios that these vehicles can encounter without requiring constant connectivity. And just think about all of the situations that mining vehicles have to work in, and including all of the areas where connectivity is just very difficult. And by the way, critical materials are in super high demand. There's, of course, electric vehicles and renewable energy. They drive a lot of demand for these very specific materials. And so mines are actually under a lot of pressure to deliver more material even faster. And the labor shortage is a real problem. So in the US, about 200,000 mining workers are set to retire by 2029. And that's actually more than half of the current workforce. So these problems are not only real, but there's also real urgency to solve these problems. And our technology in this field is going to absolutely scale and have a huge impact. Next, I want to talk about the trucking industry, and I'll highlight one partnership we have with Isuzu. So Isuzu is the largest truck manufacturer in Japan. It's a global company. It sells in 150 countries. It's actually the #1 commercial vehicle seller in 27 different countries. And Japan has a really interesting population situation. So roughly, it's an overall aging population. And truck drivers, there is a labor shortage, and so the people that are in the profession are actually overworked. It's actually considered a public health problem in Japan. And 84% of drivers in Japan have faced health problems that are related to overwork. And so in response to the public health problem, the Japanese government revised its labor standards, capping annual work hours at 3,300 for truck drivers. By the way, that's averaging over 60 hours a week for truck drivers. That's the new cap. And in doing that, it's actually created a driver shortage for an industry that's already anticipating a labor decline of 36% by 2030. So this problem in its whole is known as the 2024 problem. And you can look this up, and there's a lot of detail about this problem in Japan. And it's going to disrupt the supply chain and challenge also Japan's reputation for excellent service in the country. And so this is a national priority in Japan. And so the government is encouraging vehicle makers to bring autonomy to market quickly. And we're right in the middle of that. And so recently, the Japanese government ran a DARPA Grand Challenge style competition, so to say, for autonomous trucks in Japan. And Isuzu used our technology in that. It's not just a short demo. They actually drove 3,000 kilometers over 7 days, navigating every imaginable traffic situation. So highways, service areas, merges, lane changes, tunnels, cut-ins, daytime, nighttime, rain and shine, yeah, all kinds of complicated intersections and parking. This is all done autonomously, and this was using our technology. And our partnership with Isuzu gives us an OEM partner who can actually develop the reliable chassis, which is needed for level 4 technology. And they also bring deep know-how of manufacturing. They understand the local market, and they're going to help navigate, of course, all of the government regulations. And so Isuzu is targeting to commercialize this technology and commercialize this autonomous vehicle that you see on the screen here by 2028. And our partnership will have a very meaningful impact on this critical driver shortage in Japan. And by the way, we're also running these vehicles in the United States, and it's actually the same software that can drive on both sides of the road. So it also gives you a sense of the flexibility of the underlying technology. And we're currently working on deploying our next generation system in Japan, which is really designed more for manufacturing and scaling. Lastly, I want to talk about vehicle intelligence in defense. And the war in Ukraine has really changed modern warfare quite significantly, and that is by showing the power of low-cost drone warfare systems. And in a modern battlefield, drones really are the centerpiece of war. What you see in this video clip is a US Navy destroyer launching an SM-2 missile, which costs about $4 million, to shoot down a $30,000 drone. Now, it doesn't take a lot of thought to realize that if you have that kind of asymmetry in costs on different sides, in this case, this was a Houthi drone that was being shot down, it's impossible to win a war in that environment. And the reality is the United States today has a lot of systems that are very expensive, and we don't have very many of them. And in order to regain a competitive edge, we have to bring greater intelligence to low-cost vehicles that can be produced in higher volumes. So highlighting just some examples of this, Applied, we've actually integrated our technologies, again, our tools, our operating system, and our autonomy stacks with well over a dozen different vehicle types in the defense industry. I'll highlight one specific example, which is Avex Aerospace. They're a vehicle manufacturer for Group 1 to 3 unmanned aerial vehicles, and they're a provider for the Army's Launched Effects initiative. And this is really allowing soldiers to launch very, very small drones that can do interesting things in the battle environment. And fundamentally, the Army needs smart weapons to increase warfighter lethality and survivability in the modern battle environment. But really, it's not just about single vehicle autonomy, it's about collaborative autonomy. And that's where things get really interesting. Collaborative autonomy breaks the traditional one-to-one paradigm between a single person operating a single machine. And it also enables decentralized execution of drone swarms in contested environments by integrating onto platforms at the edge. You also have a very interesting electronic magnetic warfare in this situation. You might notice that there's a good set of similarities between the types of problems that I'm describing here and the types of problems that you might experience in a mining environment, where you also have collaborative systems and limited connectivity. You can see where this is going. So in a test event earlier this year, Applied and Avex Aerospace successfully executed 19 missions at 100% success rate. This was the only system from any of the vendors that were tested to even get close to that level of success. And this is a perfect example of how vehicle intelligence can be leveraged in defense use cases. And in fact, the Secretary of Defense has now mandated that every Army brigade is going to have launched effects by the end of 2026. And that's actually thousands of platforms just for this type of technology. So this absolutely will scale. So this gives a sense of how we're scaling vehicle intelligence to the whole world and working with all of the great vehicle companies in every corner of the globe. And really, this is about improving lives of consumers, providing abundant raw materials, ensuring reliable shipping and supply chains, and fundamentally also safeguarding our country. Now, we're just getting started. There's so much work ahead, and I couldn't be more excited for the things that are making their way today to scale production that will really have an impact over the next few years. Thank you.